Today we're going to quickly go through a couple of maths problems, specifically looking at log uh, values in biology questions. So this is a question about an antibiotic that's used to treat bladder infections and what they do. So there's a couple of questions about it. And so they do some tests on this antibiotic that they've developed, and they test them on bladder infections in mice. So they have three groups of mice: a control group C, and they've got a group R that was treated with pre-existing antibiotic, then they've got group A that was treated with a new antibiotic. Okay, so you need to read through this question obviously before you start. These are the results that they get. The results show on the y-axis log 10 number of bacteria in the bladder. So this is what we're looking at how do we interpret this log value, and we can see that C is high, R is lower, and the lowest is group A. So this is saying that C has got the most bacteria and A has got the least amount of bacteria. Okay, so a nice little bar chart there. First question doesn't ask about logs, it's asking about ratio and proportion. It's saying the antibiotics were given at 25 milligrams per kilogram per day. If you have a 30-gram mouse, how much antibiotics should you give it? Show you're working. So we'll go through that as a typical ratio proportion question. Then here is our log question. Calculate the percentage difference. So here is the question, percentage difference. So take note of that. It's the difference, but they want the percentage in actual numbers. So not using the log numbers, use the actual numbers of bacteria in group A and compared to group R. Okay, so it's all going to be compared to group R. And then how do you calculate the actual number of bacteria? You calculate it by using the 10 to the power of x function on a calculator. Show you're working. So both of them show you're working. So here we have 4 marks of maths for an A-level biology question. Okay, let's look at the first one. 25 milligrams per kilogram is recommended, and we have a 30-gram mouse. Okay, the immediate issue that we have here is the fact that our mouse is in grams, but they are saying you should use 25 milligrams per kilogram of mouse. So we first need to convert our grams to kilograms. So if we're going to convert grams to kilograms, what we will do is we will divide by 1,000. So 30 divided by 1,000, it means we've got a 0.03 kilogram mouse. So if we've got 0.03 kilograms of mouse, we want to work out how much drug to give it. It's 25 milligrams per kilogram multiplied by 0.03 kilograms. And that gives us a value of 0.75 milligrams of drug that we need to give our 30-gram mouse. Okay, let's go to the second part of the question that involves log values. So just to give you an idea of what a log value actually means. So these are the equations that bring log values together with exponential values. So log to the base 10, sometimes you have log to the base 2, sometimes you have log to the base e. At the moment, we're looking at log to the base 10. So log to the base 10 of a number a is equal to b. If we have to invert that or turn it into something else, turn it into the exponent form, you're looking at 10 to the power of b being equal to a. Let's look at an example. And if you look at the example over here, think of a number, for example, 100. What is log to the base 10 of 100? It's 2. And if we sort of want to make sense of that, we can look at this over here. 10 to the power of 2 is equal to 100. So I'm not going to try and teach you logs if you haven't done maths, but if you are interested in how this function of 10 to the power of links to logs, this is how they relate to each other. Okay, so you have been asked to calculate the difference between A and R, but not using the log values. You have to get the actual numbers. And once you've got the actual numbers, then you find the difference. And then ultimately you need to find the percentage difference between A and R. So the first thing that we need to do is we need to read these values off the graph. That's the kind of thing you have to do really carefully. Please don't try and guess it. So be really careful, because you'll see that these are actually these lines are halfway between these small squares. So read them nice and carefully. And what you'll find is that the log values that you read off the graph for A are 1.25, and the one that you read off for R is 2.85, okay? It tells you in the question to use 10 to the power of X in order to get the actual number. So what does that mean? We say 10 to the power of 1.25. Okay, so to get the actual values here, we're doing 10 to the power of 1.25 for A and 10 to the power of 2.85 for R. Okay, if you're unsure of how you'd actually do that on your calculator, so on my calculator here, okay, if I look at my calculator, I have got a function over here, 10 to the power of X. I push that function and then I put my number in, 1.25, and I get 17.78. So call it 17.8. There, 17.8. And then if I do the same for my other value, 2.85, I get 707.9. Okay, I'm probably keeping in a few too many numbers here. 707.9. All right, so those are now my actual values. So I've got my actual values, all right? So now I need to work out the difference between them. Whenever you hear difference, you know it's a takeaway. So 707.9, subtract 17.8. And if I do that, I get 690.1. And then, so there's my difference. Oh, that should be rowing out. There's my difference. And so there's my differences done. So now I need to do the percentage difference compared to R, okay? Here is R is 707.9. So the percentage difference, there's the difference compared to R, 690.1 compared to R, 707.9. And if you want to calculate the percentage, you multiply it by 100, and what you'll end up with is 97.6%. Okay, so that is how you use logs in a maths type, in A-level maths type question.